video on YouTube after I edited it a little bit. So we are checking now, hopefully successfully. I need to test the code, to be honest, but I will going to make one test for everything. Only to this box. We need to move here, then move here somehow. So the first move doesn't change the row. In other words, it doesn't change the J, but I get difference. First I is here, then I is here, plus 3, then I is here. So imagine oh well Sudoku, the more numbers they give you, it's easier. So if they remove a lot of numbers and you see that there's only 7 numbers in the whole grid, yeah, that thing, even I am not good at it. Actually, I'm mediocre. I'm not that good either. I played Sudoku and I saw some advanced Sudokus that there are some shifts in the columns, in the rows, and oh my god, no thank you. I'm not that good. No thank you. So there are other advanced type of Sudokus. I'm good with this one only, and if there's enough numbers. If there's like 5 numbers in the whole row and column, or the whole thing, you see like 12 numbers in the whole grid, screw that. I mean, like this one, look at that. This one is difficult. It takes more time. It takes at least an hour for me. Some people can do this in less than 15 minutes, but I'm not that good. This one is good. This one is easier, but you can even see easier, like this one. Oh my god, this one seems really easy. It's already like half solved for you. It's all about thinking about strategies, because just like chess, you can think one step at a time. Like, is this number in this column? Is this number in this column? Then you think in another step. If this number is not in this column and this row, then could it be in this and column? And if this number could be in this row and column, then it must not be in all of these. So you go to the second step, then you go to the third step. And if this number, if it could be in here, then it shouldn't be in all of here. And it shouldn't be, if it is in here, then it shouldn't be in all in here too. So you build up. So the more advanced and more training you get in Sudoku, you learn how to think further in other steps. Like in the second step, if this number should be in here, what's the second step? What's the third step? And third step is way too much for me. I stick to the second step at least. But third step, yeah, I don't know if some people go to the 4th step and 5th step, but in chess, people go to the 7th step, chess masters. So it's possible. Sudoku is much easier than chess. The number of possibilities is way much less than chess. So yeah, as I said, we need to jump the jump the I plus 3, and then jump it again plus 6. So that mean is equal to 3 over 3, no. That mean we can invent a for loop in here. Let's give it a try. Let's give it a try and see where this is going. So we invented a number that it goes 3 times. If we are going to keep this code like this, without changing this part of code, I'm trying to make an educational code how to solve Sudoku. So, oh, he left before I do anything. If I didn't change the code in here, it will check this box 3 times. But what if we move the I by this number? What I mean is we say I is equal to I plus IK multiplied by 3. Now the I will start from, and of course we need to add this in here. Now the I will start from 0 and finish the whole box for the first run. So I will start from 0 and always go like this. I 0, 1, 2, 0, 1, 2, 0, 1, 2. Finish this loop and we enter this loop, the IK loop. What will happen, will be equal to 0 plus IK multiplied by 3. The first run, IK is 0, so the 3's just disappeared. The second run, IK is 1. So now we have IK is equal to 3 plus 0. So 0, 1, 2, 3. Look at that, we started from here. And we will do the same loop because Z is depends on I. And I is depends on IK. But what about the other row? Yep, it goes all around. Because now, when we finish with this rectangle, we start with this rectangle. Why? Because IK is 2. And 2 multiplied by 3 is 6. And 6 plus 0 is 6. So 0, 1, 2, 3, 4, 5, 6, 7, and 8. The same thing with the columns. We need to shift the columns every time. So when we finish this fiasco, check this rectangle, check this rectangle, check this rectangle, we just make another loop in here. Maybe I need to do more ads to my own programming, because I believe I'm not doing that bad that I don't get audience. If we leave the code as it is, it will check this code 3 times. But we are going to do the same freaking trick. We are going to add JK in here, And Z depends on I. And J. So the calculation it will be automatically calculated. And with that, I believe we check all the boxes. And this is actually, if you calculated the step, is exactly less than 81. Actually, this one is exactly 81, sorry, because we didn't skip any step. Let's calculate it together. 9 multiplied by 3. This is always 3 because the plus here is same in here, same condition. Multiplied by 3, multiplied by 3, multiplied by 3. So these two 3's are 9, these two 3's are 9, and this is another 9. Whoops, 81 multiplied by 9, sorry. So 240 something. It's same with here. But this one's shorter because we have reduced one number in here and we reduced one number in here. So we shipped off a little bit from there and there. So what we are going to do, oh wow, yeah, We are not done yet. We are not fucking done yet. This only checks if the solution is correct or not, actually. We are going to do console, right line, and print the Sudoku. I need to close the window. The light is so strong. Oh shit, it's already closed. It's blinding my screen. It's the sunrise. And it's valid. Of course, after all of that, it should return true. To test this, let's test the first one, the first input we have. False. Interesting. What am I doing? I don't think this one falls because we took it from the internet, and I believe that's a valid Sudoku puzzle. But let's just humor ourselves and check every row or every box first. All of them unique, all of them unique. Unique, 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 and unique. Yeah, apparently this is a true Sudoku, so our function is screwed up. Congratulations. Yeah, if you see me not sure where the button is, it's because the glare of the sun. Even though the thing should cover the sun, but it's not covering it. Oh, what am I doing? Okay, cool. So let me check where does it fail. Let me check where does it fail. Actually, let's just do the last step. Because maybe I done something really stupid. So let's check one by one. Yeah, I should test each part alone, to be honest. Let's do that. So there are easier ways to test, because instead of clicking F5 180 times, let's do it in the easier way, because this might be the safest way to do it or whatever, and I didn't add watch or whatever, but we could use console, right line, and then we say is data plus I j is equal to p. And actually, no, sorry. So here we see all the checks, and for some reason, okay, here P is 5, and it checked all the column. It checked 6. Oh, checking the column. 0, 8, 4, 7, 0, 0. And then it checked 6, and it checked 4. No, sorry, it checked 6. What? Yeah, I walked it up. If I'm going to check the columns, I should check 3. No, right. I checked 6, and I should compare 6 with 0. No, correct. So, is this one is 6? No. Is 0 is 6? No. Is 8 is 6? That's the question should be. Here. Is 8, 3, 0 is 6? Till 8, 0. So we don't need to check the last one. Because if all of these guys unique, it shouldn't check the last one. Then it checked 8. And it checked it 1, 2, 3, 4, 5. 1, 2, 3, 4. It shouldn't check it 5 times. So it checked 4. 0, 1, 2, 3, 4. Which is the correct one. So it checked if 4 is equal to 8. 7 is equal to 8. 0 is equal to 8. 0 is equal to 8. 0 is equal to 8. What the hell? Why is there a 9th 0? A 10th 0. Oh, 8 is the last position, silly you. 8 is the last position. You shouldn't check it. You shouldn't check it. You shouldn't check it. Because if this one unique, and 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 this one unique, not unique, not the same. No, you need to check it. Sorry. You need to check it because maybe the last one is 8. Then it fall on its face. Well, what's going on? What's going on? It should check 8, 4, and 7 after 8. So 5, 6, 8, 4, 7. Then it start checking 3. Oh, correct. It started from this column, and it start over. 9, 0. He just ignores 0. 6. He checked it only twice. Perfect. Then 8. Here, because this is 0, this is 0. He ignored them, and these ignored them. And then he should jump to 1. Here. 8. And then 4 only once. This one. So it seems it's working. 7, 9, 5, and it's working. So the column check is correct. Let's do the other check. So this guy has no problem at all. And here, let's do the same thing. And I believe I already can tell there's a problem here. It might be, the problem might be the last algorithm. Because as you can see, the last algorithm was a little bit whacked. So here we need to check JZ, not ZJ. And JZ, and we compare it with B. So let's give it a try. Let's load the Sudoku and check if it is valid. So here it seems it passed correctly too. And because it's almost the same code and I mirror it, let's check the last one. The last number he checked is 7. This one. Because we are checking row by row. And before it is 8, which is this one. So it's correct. This is the correct way to check it. So the last problem, the combination that we made, is this guy. This is the problem. So let's check our abomination. So abomination. There's an A. Oh. Yeah, this abomination is a little bit dangerous. God. Console, right line. IK is equal to IK. JK is equal to JK. Is data I no Z over 3 plus, I'm trying to check the algorithm at the same time, checking if what I'm writing is correct, is equal to P yeah, imagine you write that in your script interpreter, and in the script interpreter you're using a function if, you'll see a lot of parentheses and quotation mark and skip characters. It's so fun. It's so fun. Not really. So as I said, the abomination failed. So let's see what's going on. So he is still working on the first box because IK and JK is both 0. Let's adjust the font. I hate it when I pause my mistake and the program page immediately jump on my face. It's funny, it's valid when it's all empty. Yeah. So he didn't jump. No, he jumped he finished the first square and it passed. The second square is screwed up. So let's go and look. So the second square, he says, is data 1 of 1, which is this one. Oh, crap. Why did he start there? 2 of 1. Yep, the jump is totally screwed up. Let me check what Z is equal to. And let's check this. What is equal to? Alright. Alright. I wonder if any of you came from the Facebook. I put the stream on there because someone is asking the Facebook if someone can solve this problem, and I'm trying to do it online. So C is 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry, 8. Then it became 4. Excuse me. So it checked this one, then this one, then it checked 0, 1, sorry, 0 and 1, this one. So it's doing correctly so far. Then 1, 1, then 2, 1. Then it should be 0, 2. Look at that. So it's doing correct. And then 2, 2. And all of a sudden it became 2, 0. Because it finished with 5 and started with 6. What? Then it started with 3. Then it started with 9. Then it started with 8. Then it says false. Okay. When we compare the 5, we compared like this. Then we took 6. When we took 6, we compared with 2, 0. 2, 0. And the second one is 0, 1. 0, 1, 1. 0, 1, 0. 6, 6, then 1, 1, sorry, then 1, 1. So why did the 5 checked? Oh. Yeah, the 5, it checked it by row. But 6, it starts checking it by column? What the hell? How did I do that? Tell me, how did I do that? Anyway. No, it started the second one. No, sorry. It checked it's the second one. And the second one is 3. Sorry. So 6 is compared with... At first, it compared with this one. I don't know why. So this tip is completely whacked. I don't know why. Then it compared with 3. Then it compared with 0. Then it compared with 9. No. The second one starts checking it by column. How did I do that? The first one, it checked 6, 3. Oh, no, sorry. My mistake. The first one is checked by column too. My mistake. So all of them is checked by column. So the mistake is when we try to travel to the second one. And I start to see the problem. Let's reverse them. It's just a hunch, by the way. Nope, we screwed up from the first one. Nope. So let's take the readings and think what the hell is going on. So Z, for some reason, started with 4. Then I should add the IK in here, multiply by 3. Because we don't need to compare the first fuse with the second. We need to increment the blocks, the pivot, and the value that we check. So we invented these values, IK and JK, to move the whole box from here to here and then to here by taking this value from 0 to 3 and multiply it by 3. So the first row starts 0, 1, 3. Sorry. First I is 0, 1, 2. And then J become 1. And become 0, 1, 2 again. But J is 1. Then J become 2, 0, 1, 2. And we finish the first code to check, which is this one. You can pause and check this code to see what I'm saying. And actually an hour ago or 30 minutes ago, I described the whole thing. Then we invented this number to jump the IK, to jump the I. So instead from 0, we made I is equal to 0 plus IK multiplied by 3. So IK start from 0, so the first box didn't do anything. But when we incremented IK into 1, then I became 0 plus 1 multiplied by 3, which is 3. So it became 3, 0, 1, 2, 3. So we start from here. But J is still 0 because JK we didn't implement it, increment it yet. So we check I 3, 4, 5 and then go to J1, 3, 4, 5, 3, 4, 5, and then we increment IK again and it becomes 6. So this is 6 and 6, 7, 8, and it increments 3 times. So, but the pivot, we didn't move it. We didn't add the incrementation. So let's give it a try. Of course this is true because this is empty, so it's valid. Worked! That's the problem. That's the problem. We didn't increment the pivot. We incremented only the check value. And if you ask what does al-Khwarizm or algorithm in English, or Khwarizmiyat in Arabic, or al-Khwarizm Arabic English is the mix between the two. This is the whole point, how to analyze the problem and build a solution. Now let's return this part. The only problem with this code is check the whole Sudoku. Can we somehow take two numbers and check it partially? Like, can I say, well, I want to check the Sudoku from here, and we go on. The only problem is I started with column and then started with row, and it's confusing, and this one's jumping all the way around. So if my code is a little bit smoother, or if I'm in the mood, I should be able to add two integers in here to point out where do I want to start and where do I want to end my search. So we can use it to make a valid solution for finding the solution for Sudoku. So what we are going to do, we are going to do something called brute force. We are going to try to take the Sudoku we have and check if it is valid. If it is not, that's another story. If it is valid, we check if the next number we have, and if it is not empty, how to put it, slowly, we check the current version we have, if it is valid or not. If it is valid, then we check the first empty number, and we will put a random number 1. Then we check if it is valid. If it is valid, we continue and we add another number 1. If it is not valid, it go back a step and try another number 2. It's valid. Yes. Yes. And the whole box, yes. It checked the next number. It's full. Next number 1. It's valid? No, because there's a number here. It remove it. It check another number 2, and it keeps on. If it gets stuck, it can go back even this number, empty this one, and go back here and start changing this number into 3, and it keeps on till forever, till fucking forever, till it find a solution. The only way that it gets valid solution is when we reach the last number and we put the number and if it is valid. So we try 1, 2, 3, 4, 5, 6, 7, 8. If one of them is valid, success, we found a solution. If 9 is not valid, oh my god, we need to go back, and we might go back really way back to try to the first number we put, and we add increment that number. If we use all the solutions and none of them valid, then the original Sudoku we sent is not valid, which is not, cannot be, because we cannot accept invalid solutions in our brute force. So okay. So first step is we send the Sudoku to the brute force only when if it is valid. Let me make a Sudoku for saving the result when it find yeah, here, Salute. No, this program is C# EXE, so it will work on any Windows platform. No, I'm not doing a program for Facebook. Someone in the Facebook put a challenge. If you can solve, you can make a program to solve Sudoku, and I'm doing that for him. This is not a Facebook game. This is a C# program, and it works on, yeah. So usually Facebook use Flash. I don't know if they use similar things like HTML5. No problem. They might support C# but not EXE folders. You need to do something to do that. So what I did was just checking valid. We are going to use that function to build our brutal force. And actually, recursive are very powerful way to program, but it's really hard to write. And I haven't done recursive for more than 6 years. So pray that I will do it right. Pray that I will do it right. So we need to decide the first condition, and the first condition is if x is equal to 8 and y is equal to 8, and this is called the base condition or whatever, which return the correct solution, and Sudoku class SS is valid. Of course, not this SS. We need to add a value to the SS. So we need to add a number to this SS, which is the Sudoku object. So actually we need to add a pivot in here too. Great. And the pivot is a byte. Not a pivot, a value. Let's call it V. Just like when I done with the other algorithm, sometimes you don't think exactly what you're doing. Sometimes you don't do that. You just build an idea in your head and you try to go on with it. And I'm trying to, with my best, to give you what the hell is going on in my head. So what I'm trying to do is to make a function, as I said, add a value to the stupid Sudoku, only when it is not valid. So I'm building a base case in here, and I might need a helper in here, I don't know, but we will see, because we might do it from both sides or whatever, you never know. So actually the first thing is, because we know this sucker is valid, we need to recall our function if the number is not 0. So here we say O, and I pressed F and pressed space and instead of if, and he gave me something random. SS X Y. Do you remember the this override? This function. This one allow you to override the parentheses. So here, if this one is greater than 0, then return this function with SS V X plus 1 Y. But we need to be careful, because if X is greater than 8, hopefully you are following, this is recursive stuff. If X is greater than 8, then X is equal to 0 and Y is plus plus. And we do this. So actually We could save these steps by writing 0 here and y++, but let's slow down. The problems with y++ is if y is equal to 9, then we should check this one. Because the base case should be the first one that returned the true value. This is the ultimate force. This is the ultimate value. This is like everything. This is like the final result. The one after is changing a value. But in here, y cannot pass 8. Because we are going to from here to here. This one can pass 8. So it go here. And here is y is 1. So y 0, 1, 2, 3, 4, 5, 6, 7, 8. Y can never pass 8. Repeat with me, people. Y cannot pass 8. So this condition must pass here. If y is greater or equal to 8, then return false. Y greater than 8, sorry. Because here we can use this now. So if x is greater than 8, recursive with x is equal to 0 and y++. Else, which is here, return it with x++ with y. This is only when SS is equal to 0. Sorry, greater than 0. That's mean the numbers we are just passing. If the number that we found is not 0. Oh, wait. Okay. If the number is not 0, then it is here. And here we add plus plus. Now if v is equal to 9, where do we add this check? You see, we are going to actually, no, sorry. This one will return the exact same number. So in here, when this is 0, then we add 1. Then it check. If it is 1, then it will go to the next one. If it is 0, it will add 1. Then it check the next one. No, actually it will check if it is valid. No, it doesn't check if it is valid. What the fudge? It doesn't check if it's valid. It will go all the way here. Then it will check if it is valid or not. Maybe I screwed up somewhere. Yeah. Let me follow it step by step again. It will add 1 everywhere. And if it is not valid, there is no condition where it's not valid. And maybe this is why we need the helper. Because we need to make a way to step back. Yeah, I'm kinda not very good in the recursive, but I can feel it. I'm almost there. We need just to do one silly step and we're done. But this is a question, where's the silly step? The thing is, I'm not happy with this base case scenario. This is not the best that the nations can make. The question is, I'm not checking if it is not valid. We need to check if it is not valid somewhere. Let me drink something. Any help? Great programmers of the years? From the west and the east, where you can find all the common folks, what they fight for real, to make a better algorithm in all the world. Dun dun dun. Some silly 90s cartoon or something. So the question is, when this is not valid, it reached the last step and it will increment the y and return false. No, we need to step back somehow. This is not the good way. We need to check if it is not valid, immediately return back and try again. I just said it. Oh, this is the problem. The problem is I didn't replace the value of xy with v. Let's make a sitter. So now we replace the SS with the current location with V. Now we should say if SS is valid, then we do this. Else we do this. Yeah, I'm thinking. Actually, this else doesn't have any meaning at all. Because if this one is not valid, it will come here. Hopefully you are familiar with recursive. I haven't made one for a very long time. And actually, I'm much better than before. And that's the sad part. I was really sucks at them. Really sucks at them. Here we put a number in the stupid empty space. And we check if it is valid. If it's not, we need to try another number. If it is yes, then we start from 0. But x, we add 1 to it. Yeah, actually this condition in here is here. Someone answered in the Facebook. Let me see. No, this is yeah. It's complaining about not being able to sleep because I was complaining to him. So anyway, if it is valid, we increment the x with 0, no, with 1, sorry. So we start again from the next box, but with 1. If it is not valid, then we will try again with another v. And this is the sad part. If v is greater than 9, then we made a mistake. If v is greater than 9, then the whole step is not good. So we need to go back. I kind of forgot how to do that, to return back. And maybe you're right when you said if, else, then. So here, we need to go back. We don't need to try, because we completely failed. We screwed up big time. But in here, if it is less than 9, no, less or equal to 9. I believe we are almost there. We are almost there. Ah, yes. We need to remove one of these stupid conditions. We need double return or something. We need to do a double return. Only in recursive we might have more than one return. I wish if my instructors take a look on me and see how screwed up am I, because but we are almost there somehow. We need to think harder on this. Does mean more drinks, I guess. I wish if I can drink coffee anymore, damn it. Let's go back and check what the hell is going on. Let's walk it step by step. If x is greater than 8, then we return increment within column. If x is 8 and y is 8, and the whole Sudoku is valid, then we win the game. Return true. If he incremented by mistake somehow and y became 9, then we return false. And actually this can be the first condition. If the box is empty, then we increment by 1. No, this is wrong. This is wrong. This is not correct. Well, this is just like incremental, and actually this can be iterative. So actually we can advance x and y in here. So in here, we're going to say if x, y, the value is not 0, then we will increment x. But if x is equal to 9, x is equal to 8, 0. Y plus plus. Or and we need this condition again. So this one, no, return false. So if this one filled this number, it will check this one next time, and it will return false. We'll check this one, and then it will increment, then it will return false. Okay, let's go to the end. Here we put the values that we have, 1, 2, 3, whatever, and check if it is valid. If it is valid, then we increment x, and we go to the same fiasco. If 9 is not valid, then return 0 x plus plus. No, we return the previous value. Yeah, welcome to see me scoring up in the recursive. No, this is not correct. I remember the base of the recursive must be at the beginning. Did I screw up? Did I really screw up? The only condition that is valid is in this case. What do we do if v is greater than 9? I want to cancel the step and go back, track back. How to do the track back? Yeah, I give up. We will cheat a little bit. No, not Wikipedia. Wikipedia will tell you what the hell doesn't mean. Yeah, I'm sorry for that. I haven't dealt with this. I haven't seen academic work like this for recursive in Java for a while. So this one print into if only if they are equal, and this one will print an increment itself. So if you say 5 7, it will print 5 6 7. So this is the base case. Okay. So the simplest problem is the base case. This one? I don't know. Yeah, maybe because I use this condition. And in recursive I shouldn't check if we reach the limit. Maybe that's my mistake. This sentence. So somehow we need to check if it is valid to return true. If y is greater than 8, return false. If x is greater than 8, increment y. Don't even look at the thing. If the Sudoku has no empty number, then increment the Sudoku. So actually, I could use return plus x instead of increment, but this is just for saving time. But just to save it as a recursive God's sake, and make it fully recursive, let's use recursive here. So this is just a shortcut to make the recursive into iterative. Because you know iterative save more memory. Talk slower, please. But we can do it in recursive way. Then, if it is not greater than 8, not greater than 8, we increment v. Then what? Maybe I need to increment x in here and send 1. If it is valid, we need to increment with 1. If it is not valid, we need to retry with v++. It should work. This should work. This should work. Let's give it a try. So what we are going to do after we click on solve, we do solution Sودوكو solution is equal to SS clone. And if let me print a message to tell me the original Sودوكو is not valid. And here, if this one is true, then we clone the solution and then we print it. And just to make it more fun, should I do that? Yeah, let me do that. Let's make a toString function. And let's try to print the Sudoku on here. Yeah, so I stopped talking because I started to get tired, to be honest. I've been awake now for 24 hours. Can't sleep. Thanks for the sleep disorder. And I decided to do a very stupid thing, wasting of time, just for the heck of it. Actually, if someone learned from this video after I edited a little bit, that's not a waste of time, because I try to be as educational enough as possible to show a lot of stuff. So let's take the data from each key and append it to this guy. And if you remember correctly, we can append dash n dash r dash n to make a new line. And actually in the strings you don't need dash r. It's funny to use toString inside toString. It shows you the power of programming, the power of OOP, the power of bullshit. And sorry for my language too. It's getting more horrible than ever. Okay, do you know what does this line do? Hopefully you do. Hopefully you do. Pray that we are not going to screw up the computer. What? What? Oh. We need to change a condition. We need to make a condition if it is valid and has no zeros. Let's do that. So we need to do another freaking loop. Hopefully the guy who made the boss on Facebook will be happy. A great challenge, how to solve Sudoku. Make a program to whatever. To give it a file text. I don't know if he overestimated or underestimated the challenge. But I myself underestimated. I thought I would finish it in 3 hours. So if the data has zeros, they return false. If it has no zeros at all, return if valid. And we are using is complete in here instead of making two conditions, because we need to make sure if it is complete and if it is valid in the same time. Load Sudoko and solve. Brutal force, everyone. Brutal force. I believe even the stream will screw up. Everything will screw up. Yeah, this will take forever. Let's remove this step. But now we don't know if it's going to work or not. But actually, the guy here will tell us how much memory it is taking. I don't know what's going on. Did it crash? I don't know what happened, by the way. Hee. Stack Overflow, everyone. Stack Overflow. I believe it's run out of memory. Yeah, the maximum number of stack frames supported by Visual Studio has been exceeded. Yeah. So what we are going to do, let's pick a very easy Sudoku for it. And change this value brutal force is brutal force. From its name, not very efficient. And I know this is not very efficient, and we need to cut it to make it efficient. But let me be honest. I should make this program without window form and everything to make it as efficient as possible and cut the crap that I'm doing. And I shouldn't use recursive. I should use iterative. But I didn't know that it will really stuck the memory. So let's keep the last three numbers. And give it a try. Oops. Let's check. It says it's not valid. Seems alright already, so my code is my screwed up as usual. So actually this is valid unless the sample is not valid, then this is a problem. Let's print is valid in here. Whoops. Yeah. Screw me. Screw me. Okay, let's check 2. No 2's here. No 2's here. Wow, the font is really blinding. This is not a good font. Or maybe I'm just a little bit tired. No duplicate. 1, 2, 3, 4, 5, 6, 7, 8, 9. No duplicate. Yeah, I don't think this is involved. I believe my function screwed up. It's kind of shame. It's kind of shame. Let's remove the least impressive code in here, and let's consider a duplicate in the same box is alright. No, still, what the fudge? This is starting to make me angry a little bit. No, let's do the same thing. Oh, give me a fucking break. I'm so tired that I can't even think.